The points A, B and C lie on a circle centre O, radius 6 centimetres as shown in the diagram. The tangents to the circle at A and C meet at the point T. The length of OT is 10 centimetres as we can see. We want to find the angle TOA in radians. Well, TOA is this angle here. I'm just going to call that alpha for the moment. We know that this is a right angle because it's between a radius and a tangent. So we can just use ordinary right-angled triangle trigonometry. This side here would be the adjacent, and this side here would be the hypotenuse in the triangle OAT. So therefore, the cosine of alpha would be equal to 6 over 10. So alpha is the inverse cosine of 6 over 10. And that means alpha is going to be approximately, well, first of all, we're in radians, so let's make sure we're in radians. And then we'll do the inverse cosine of 6 over 10, 0.6. And it's 0.927 radians. So what do we want to find next? We want to find the area of the region TABCT. So basically TABCT, that's all of this. So what we could do is find the area of this sector and then add it onto the area of these two triangles. That would do the trick. Now if that's 0.927, clearly by symmetry this is the same. So let's call this angle beta. So the angle beta is going to be 2 pi, take away 2 lots of what I called alpha. So that's 2 pi, take away 2 times the last answer on the calculator. So 2 times pi, take away 2 times the last answer, gives me 4.429 radians. And so the area I want is the area of the sector plus twice the area of the triangle OAT. Sorry, it's supposed to be in the subscript. So the sector is going to be 1/2 times r squared, and the radius is 6, times 4.429, plus twice. So for the triangle, we can do it at 1/2 base times height. So either use Pythagoras or spot that this is a 3, 4, 5 triangle, and therefore 6, 8, 10. And so the base is 8 and the height is 6. So 1/2 times 8 times 6. And we can calculate that. So I've got 0.5 times 6 squared times my last answer, plus now here, obviously the 2.5 cancel, so we've just got 8 times 6, which is 48. And that gives me 127.7 centimeters squared. And the last thing we want to find is the perimeter of the region TABCT. So that's going to be that length, which we know is 8, that length, which we know is 8, and the arc around there. So the perimeter is equal to 8, add 8, add just r theta, 6 times 4.429. So 16, add 6 times 4.429, and that gives me 42.57.